So welcome students. Today we will discuss about the ultrafiltration process. So as I already explained you before mid semester that ultrafiltration is a pressure driving process which is used to separate the microorganism from the water stream. So basically ultrafiltration has the membrane which has the pore size at the microns level, or it can separate out the different type of microorganism or the micromolecules from the water stream. So there are several applications of the ultrafiltration. The main applications are written here. The first is in the water purification. Ultrafiltration process is used to removal of microorganism from the water. In biotechnology field, it is used to concentrate and separation of the different macromolecules or microorganisms. So basically in biotechnology, it is used to separate out the different types of proteins, or if you want to separate out different type of carbohydrates or other type of biological molecules. So you can use the ultrafiltration, or if you want to concentrate the proteins in the any solution, so you can use the ultrafiltration process. So different type of ultrafiltration membranes are widely used in the different biotechnology labs, at the laboratory level also and at the commercial level also. So it is also used to separate out the microorganisms. If you want to concentrate some type of yeast or some type of bacteria from a solution, you can use the ultrafiltration process. In the metal finishing process, it is used to purify the, it is used in the electropant as well as it is used to separate out the oil water emulsion. It is used the spray paint also. In dairy industry, it is used to concentrate the whey protein and the protein in the milk. Basically whey protein is the protein in the milk. So in during the cheese formation, the water removed from the cheese is called the whey. So the whey protein is concentrated by the this process, ultrafiltration process, and then later that protein, the whey protein, can be used to make some energy drinks or can be used to make the other milk product like ice creams. So this is a commercial process. In pharmaceutical industry, it is used to recovery of enzymes, vaccines, plasma proteins, antibiotics, pathogens, and we can also use the ultrafiltration in the membrane reactions. So as I explained you in the previous class, in the membrane reaction, you can use the membrane based processes. So ultrafiltration membranes are used to separate out the feed stream reactant from the reactor or the product from the reactor. So basically in pharmaceutical industry also, as well similar to the biotechnology labs, in pharmaceutical industry also we can widely use the ultrafiltration membrane. In the food industry, it is used to, as for separation of the potato starch, egg white, gelatins, and the juice clarification, classification or clarification. So basically it is widely used in the food industry also. In the textile industry, basically it is used to recycle the dyes in the reactor or wastewater processing. So it can remove the macromolecules which comes with the fiber. So if you are drying, if you are coloring the cotton stream, so the wastewater comes from the cotton stream contains the several micromolecules of the different type of carbohydrate or the other plant materials. So that can be removed, then that dye can be recycled. So it is used to recycling the dye water, as well as it is used to separate out the, it is used to separate it is used to wastewater treatment. So these are the main use of ultrafiltration process in the textile industry. In other chemical industry, it is used for the polymer waste separation, waste latex removal from the wastewater. So basically in the wastewater treatment is widely used in the different type of industries. In the separation, it is also used for separation of lignins compound in the pulp and paper industry. So what are the lignins? Lignins are the aromatic compounds, phenolic compounds basically, where the aromatic ring contain the OH group. So these are the lignins, and these are the poisonous compounds also. These compounds can be used in some other purpose. So during the paper and pulp processing, the lignins of the plant will be removed with the NaOH solution. So that lignin compounds can be separated out from the NOH solution by this process. So this is also a part of the wastewater treatment. In the similar in the leather industry, in the ternary waste with the microorganism or the animal body waste which comes with the during the leather processing in the wastewater, that can be separated out by using the ultrafiltration process. In the sewage treatment plant, in the sewage treatment power plant also you can use the ultrafiltration process. And basically ultrafilter in the domestic water purification process systems, ultrafiltration process is used as a pre-treatment of the reverse osmosis process. So in the before the reverse if you are in our domestic water purification system, if you check, then you will found that the before reverse osmosis module you have a small ultrafiltration module which is used to separate out the different type of microorganism or bacteria present in the water. Now this is all about the application. Now we will talk about the different membranes used in the ultrafiltration process. So basically ultrafiltration process works on the pore flow mechanism. So why the pore flow mechanism? What is the meaning of the pore flow mechanism? In this process the membranes are the porous membranes, and basically the size of pores are at the micrometer scales. So you can separate out the different type of microorganisms from the by using the ultrafiltration process. In reverse osmosis you have the non-porous membrane, and the separation occurs due to the solution diffusion mechanism. So here the separation does not occur due to the separation solution diffusion mechanism. Here separation only occurs due to the pore flow mechanism. So a membrane might be hydrophobic or hydrophilic. In the reverse osmosis, membrane should be hydrophilic if you are using for reverse osmosis for the water based system, but in the ultrafiltration this is not a limit. You can either use the hydrophilic membrane or you can use the hydrophobic membrane. Some commercially available membranes are made of the polyethylene, polypropylene, polyamide, polysulfone and polyacrylonitrile. So a wide range of polymers can be used in the ultrafiltration membrane. Basically membrane material depends upon the process. So basically if the what is the strength of material you required. So if you required, if the pressure, cross membrane pressure is very high in the process, suppose, and you are working on the membrane based process at the 60 bar pressure or at the 80 bar pressure, the pressure of the cross membrane pressure is so much high, then you have to, of course you have to go for the polysulfones membrane, because polysulfone material has the higher mechanical strength. If you are using at the 3 bar pressure or 4 bar pressure, then you can use the polyethylene or polypropylene membrane. So in the domestic membrane setups which we used in our homes, so that contains the generally the polypropylene membranes. But in the industrial scale and high pressure setups like in the food industry and other industry, you might use the polysulfones membrane. It is also depend the processing temperature. If you are going at higher temperature, then of course you want to use the polysulfone membranes which will be stable at the high temperature. And also yeah, you can also use the inorganic membrane. Also you can use the ceramic membranes which may sustain very high temperature, and it depends upon pH range also and the cleaning requirements also. So suppose in the cleaning you need to use some type of corrosive material, corrosive chemicals, you are using the acid for clean the membrane, or you are using some other, you are using the steam to clean the membrane, then you have to go for high strength materials. Now ultrafiltration membrane are also are classified based on the minimum size of molecule which can be removed from the feed or the pore size of membrane. So basically if you are going in the market to purchase the ultrafiltration membrane, so the range of ultrafiltration membranes present in the market is depend upon the pore size. So it may come at around 1000 Dalton pore size, or 5000 Dalton pore size, or 10,000 Dalton pore size. The range of pore size different type of membranes are available in market are from the 1000 Dalton to the 1 lakh Dalton. So this is the range of the pore size of the ultrafiltration membrane. So generally there is a range which is for a particular membrane, there is a range like 1000 to 5000 Dalton or 5000 to 10,000 Dalton. This is the range which are available in the market. Now inorganic ultrafiltration membrane are generally used in the food processing industry. Why the inorganic membranes are very useful for food processing industry? Because in the food processing industry, suppose you are using the ultrafiltration membrane for concentration of the whey protein. then you have to sanitize the membrane. So steam sanitization are very required. Why? Because otherwise the bacteria will start to grow up inside the membrane, because you are using for the food processing. And if you are using for concentrating the juice, fruit juice, or you are using to clarifying the fruit juice, means removing the different type of microparticles present in the food juice, for by using the ultrafiltration. Then you have to conscious about that bacteria should not be start to grow up at the surface of the membrane. For that you have to use the steam sanitization, with the different times intervals. So that's why you have to use the inorganic membranes, because in polymeric membranes generally the polymeric membrane cannot sustain the high temperature of the steam. Okay, so you have to use the inorganic membrane, generally the ceramic membranes. Now the module configuration which are used in the ultrafiltration membranes are generally the tubular or hollow fiber. Why? Because the concentration polarization is generally not a problem in the this process. But one more important thing is that in the ultrafiltration membrane, generally the feed flows in the shell side and product flows in the tube side. So it is opposite. It is not the feed flow in the tube side and product flows in the shell side. In ultrafiltration membrane, always the feed flows in the shell side, so that the material cannot be, the microparticles cannot be start to clog the pores of the membrane. Okay, the tubes of the membrane. So always the shell side you have the feed flow, and the tube side you have the product flow. Now there are some technical aspects of about the ultrafiltration membrane. So generally ultrafiltration membranes are the semi-permeable membrane. It selectively remove one of the compounds from the it selectively remove the solvent, and it rejects the microorganism from the solution. So unlike the reverse osmosis membrane, reverse osmosis membranes are used to separate out the salt, and the solubility of salt in the solvents like water is very high. So suppose you are separating the using the reverse osmosis membrane for separation of the NaCl. So the NS solubility of NaCl in the water is very high. It might be soluble up to the 20% or 50%. More than 50% salts can be dissolved in the water. But here you are separating out the solid microparticles. So in the reverse osmosis you have the concentration polarization. Means in the reverse osmosis we have already discussed about the concentration polarization. Concentration polarization means the concentration of salt start to accumulate on the surface of the membrane. So you have the increased concentration of salt at the surface of the membrane. Why? Because membrane are selectively diffusing the water. It is rejecting the salt. So the concentration of salts are higher at the surface of the membrane, lower at the bulk of the membrane. So that is the concentration polarization. But in this, and in the reverse osmosis, the salt is not precipitated on the membrane. Why it is not precipitated? Because solubility of salt in water is very high. But in the ultrafiltration membrane, because you are separating the solid microorganism or solid particles, so solid particles start to concentrate or start to deposit at the surface of the membrane. So it make a gel type layer. So it is different from the concentration polarization which we have studied in the reverse osmosis. So what is the consequence of this? Due to this you cannot increase the flux at the any level in the ultrafiltration membrane. In the reverse osmosis, when you plot the JV versus JV is the flux of water, JV versus delta P is the pressure, because it is a pressure driving process. So when you increase the pressure, the flux will increase because driving force will increase. So when it is true for both reverse osmosis as well as for the ultrafiltration. So in reverse osmosis, when you increase the pressure, then you will find that the correlation of flux and pressure is almost linear. So at any pressure which you can achieve in the reverse osmosis process, you will find it is always linear. It goes from the origin. So you will find always a straight line, and the flux will increase with the increasing the pressure. But in ultrafiltration membrane, you will find after some amount of flux, after some value of the pressure, you will find that the flux will start to reduce and it will become then the constant. Then the at this point the when you increase the pressure, flux will not increase. So this is called the limiting flux in the ultrafiltration, and this is happened due to the formation of gel layer. Why? Because when you increase the pressure, the when you increase the pressure, then the flux of water will increase. When the flux of water will increase, the thickness of this layer, gel layer, will start to increase. And when this layer become the thicker, then it will start to act as a resistance for the flux, for the water flux, because it is a solid layer. So it again start to work as a resistance. So it will again then start to reduce. Then that means the thickness of the membrane is starting to increase with the increase of the pressure, and that will leads to the limiting flux, means flux become constant after some time. So this is called the limiting flux. Now this, due to this, you cannot achieve the any higher flux in the ultrafiltration membrane. Now this gel formation or limiting flux depends upon the several factors. Some of, so what are that factor? Concentration of solute, means what, how much molecules are, or the solid particles are present in the feed. Then particle size, what is the size of particle? If it is small, then the gel layer might be thin. If it is big, then the gel layer might be the large, thick. Then the physical properties of solvent. If the viscosity of, like, physical property means like density or viscosity, if the viscosity of solvent is lower, then the particles may be easily removed from the surface, so the gel layer might be thin. If the viscosity of the solvent is higher, like the concentrated solution, like of water, of the sugar, then this layer will, the particles will start to stick on the membrane, and then the thickness of gel layer might be higher. So limiting flux depends upon properties of solvent and solute. It may again depend upon the flow rate, like the concentration polarization. If the flow rate is high, then the particles start to remove due to the turbulence in the feed side flow rate, feed stream. So the particles start to remove from the surface. If the flow rate is low, then particles start to accumulate on the surface. Then it will also depend upon the pore size. If pore size and the pore distribution or pore density on the membrane, if pore densities are higher, then you might find the higher thicker gel layer. If pore density is lower, you may find the thinner gel layer, because the flux value will be lower when the flow rate is lower. And if the pores are much bigger, then the particles might start to diffuse out from the membrane itself. Then also the your layer thickness, the gel layer thickness, will be lower. So it may depend upon the several factors as reported here. Now there are one more technical factor which affects the ultrafiltration, that is called the membrane fouling. So what is the membrane fouling? It is different from the concentration polarization or gel formation. So because here you are separating out the solid particles, so there are chances that solid particles start to insert in the pores of the membrane, and it works on the pore flow model. So suppose the pores of the membrane are blocked due to the solid particle, then your flux will reduce with time. So that is called the fouling. The fouling is the one directional phenomena. So once the membrane is fouled, it cannot be regenerated easily. Okay, it will the performance of membrane will reduce permanently. Okay, so when you start to use a ultrafiltration membrane or ultrafiltration system, so you will find that with time the value of flux will reduce, then it will become constant. So this reduction of flux with time is called the membrane fouling. It occurs due to the pores of the membrane start to block with the due to the presence of the microorganisms. So generally after some time you need the cleaning, but that cleaning also cannot generate the membrane permanently. Okay, it may generate the membrane up to the some percentage, but it cannot generate the membrane permanently. So fouling is the phenomena when the membrane pores are blocked due to the solid particles. So solid particle entered inside the pores and it will block the pores. In the gel formation, you have the gel layer on the surface of the membrane. So this gel layer can be removed during the process. So you need not to stop the process and then clean the membrane. You can increase the temperature, you can change the temperature, you can change the pressure, or you can increase the turbulence inside the system by using some type of by increasing the either the flow rate, or by using some other method. You can remove this gel layer. So for removal of gel layer, you need not to increase the you need not to increase to stop the process, and gel layer will be the used to define the limiting flux. So if you increase the pressure, you will find a limiting flux. Okay, so this is the different phenomena, and the membrane fouling is the different phenomena. In membrane fouling, membrane is permanently damaged due because the particles start to enter the pores. This is the different phenomena. I am not discussing here about the transport phenomena of ultrafiltration because it is little bit complicated, and especially complicated for the students which are not related to the chemical engineering background. So I am skipping the transport phenomena of the ultrafiltration. But whatever we have discussed here, which is, it is enough to understand the process of the ultrafiltration. Now in the next some lectures, I will giving you the material which we have already covered before the mid semester. So you can revise that. That will also come in the exams.